Good morning, everyone. Myself P. Vanitha, working as assistant professor in the Department of Electrical and Electronics Engineering. Today, I am going to present the topic wind PV hybrid system which is an important renewable energy generation system. This system combines two renewable energy sources, namely solar photovoltaic energy and wind energy. To provide a reliable and continuous power supply, hybrid systems are becoming increasingly popular because they improve energy availability and reduce dependence on conventional fossil fuel based power generation. In this presentation, we will discuss the introduction, components, working principle, advantages, applications, and challenges of wind PV hybrid systems. A wind PV hybrid system integrates solar photovoltaic panels and wind turbines for electricity generation. The main reason for combining these two energy sources is that they complement each other naturally. Solar energy is available during daytime when sunlight is present, whereas wind energy may be available during cloudy weather, nighttime, or different seasons. If only a solar system is used, power generation stops during the night. Similarly, if only a wind turbine is used, power generation depends entirely on wind availability. By combining both sources, the system can generate power more consistently throughout the day and year. This improves reliability, increases energy protection, and reduces interruption in power supply. The wind PV hybrid system consists of several important components that work together efficiently. First, the solar PV panels convert sunlight directly into DC electrical energy through the photovoltaic effect. Second, the wind turbine. It converts the kinetic energy of moving air into electrical energy. Third one, the charge controllers. It regulates the charging process and protects batteries from overcharging and deep discharge. Fourth one is the battery storage systems. It is stores the excess energy generated by solar panels and wind turbines for future use. The fifth one is the power converter or inverter. It is used to convert the DC power generated by renewable sources into AC power required by most household and industrial loads. Finally, the energy management system acts as the brain of the hybrid system. It monitors power generation, battery status, and load demand, ensuring optimal utilization of available energy resources. The operation of a wind PV hybrid system is simple and efficient. During sunny weather conditions, solar PV panels generate electricity and directly supply the connected load. When sufficient wind is available, the wind turbine also produces electrical power. When both solar and wind sources generate electricity simultaneously, the excess energy is stored in the battery bank. This stored energy serves as a backup source during periods when renewable energy generation is low. For example, during night time, there is no solar power generation, but wind energy may still be available. Similarly, during warm weather conditions, the batteries can provide stored energy to the load. The energy management system continuously monitors all components and controls the flow of power between sources, storage systems, and loads. This ensures uninterrupted electricity supply and maximum utilization of renewable energy resources. Wind PV hybrid systems offer several important advantages. The first advantage is higher reliability. Since power can be generated from two different renewable sources, the second one is continuous power generation. Even one energy source is unavailable. These systems significantly reduce this dependence on fossil fuels, thereby decreasing fuel costs and environmental pollution. Another major benefit is the reduction of greenhouse gas emission, which helps combat climate change. Hybrid systems also improve energy security, especially in remote and rural areas where grid connectivity is limited. Because solar and wind resources complement each other, the required battery storage capacity can be reduced, lowering overall system cost. But finally, these systems have relatively low operating and maintenance costs. After installation, finally, these systems have relatively low operating and maintenance costs of- after installation, making them economically attractive in the long term. Due to their reliability and flexibility, wind PV hybrid systems are widely used in various applications. One major application is rural electrification, where extending transmission lines is difficult, where extending transmission line is difficult and inexpensive. They are commonly used in remote villages to provide electricity for homes, schools, and healthcare facilities. Telecommunication towers use hybrid systems to ensure continuous operation in insulated locations. Telecommunication towers use hybrid systems to ensure continuous operation in isolated locations. They are also employed in water pumping systems for irrigation and drinking water supply. Many street lighting systems use wind PV hybrid technology and energy efficient operation. Agriculture farms benefit from these systems for powering irrigation equipment and storage facilities. In addition, hybrid systems are used in island power systems and remote research stations where a reliable and sustainable energy supply is essential. Although wind PV hybrid systems provide many advantages, certain challenges must be considered. The primary challenge is the high initial installation cost. Since multiple renewable energy technologies and storage systems are involved, another challenge is the need for proper site assessment. The location must have adequate solar radiation and wind resources for effective operation. Since both energy sources depend on weather conditions, power generation can still vary over time. The system also stores sophisticated control and energy management systems to coordinate power generation, storage, and consumption efficiently. However, with continuous technological advancements, improvements in battery technology, and a decreasing equipment cost, these challenges are gradually being overcome. Thank you for your attention. To conclude, wind PV hybrid systems to provide a sustainable, reliable, and environmentally environment friendly solution for electricity generation by combining solar and the wind energy resources. These systems ensure continuous power availability and contribute significantly to the development of clean energy infrastructure. I hope this presentation has provided a clear understanding of the concept, operation, advantages, applications, and challenges of wind PV hybrid systems. Thank you.